We're about to dive into a process that is absolutely critical for our modern world, but it's something almost no one ever sees. We're talking about the science of making massive, brand new industrial equipment perfectly clean before it's even used for the first time. It's a weird question, right? I mean, we all just assume that something fresh from the factory is pristine, ready to go. But in the world of heavy industry, we're talking giant pipelines, massive processing plants. That assumption isn't just wrong, it can be downright dangerous. So let's pull back the curtain on this because it's a surprisingly dirty little secret. And it all starts the second a new piece of equipment is even made. On the outside, what do you see? You see gleaming, perfect steel. It looks totally ready for action. But the reality? Well, it's a lot different. Hiding on those seemingly perfect surfaces is a whole cocktail of contaminants, gunk left over from the entire manufacturing and construction process. So what kind of stuff are we really talking about here? Well, you've got things like mill scale, that's a flaky surface that forms during production. Then there's welding slag, which is all the residue left over after you join two pieces of metal. And that's not even getting into the obvious stuff like rust from sitting in storage or the oils and grease that get on it during transport. Oh, and, just plain old dirt and debris. And here's why this is such a big deal. All this microscopic leftover junk isn't just a bit of dust. Nope. It can actually clog up entire systems, corrode pipes from the inside out, and even contaminate the final product. Ultimately, it can lead to catastrophic failures. So this isn't about making things look pretty. It's about structural integrity and, most importantly, safety. Okay, so that's the problem. Luckily, there's a highly specialized science designed to solve this exact issue, to make sure that brand new actually means perfectly clean. And it has a name, pre-commissioning chemical cleaning. Think of it as the official mandatory startup procedure for any major industrial system. It's this incredibly deep clean that happens just one time right before the equipment is commissioned. That's industry speak for being turned on for the very first time. So how does this actually work? It's definitely not as simple as just hosing things down. It's a really precise, multi-stage operation. This whole process is incredibly methodical. First, they start with an inspection to see exactly what they're up against. Then comes mechanical cleaning to get rid of any of the big, loose stuff. But the real heart of the operation is the chemical cleaning stage, where they use these specialized formulas to dissolve the really tough gunk, like rust and scale. After that, the system is neutralized and passivated, which is a cool process that creates a protective layer to stop rust from forming again. And of course, it all ends with a final inspection and a mountain of paperwork. Now, look, cleaning out a simple tank is one thing. But what do you do with a pipeline that stretches for miles and miles? It's not like you can just crawl inside with a scrub brush. The sheer scale and the lack of access points, that requires some seriously clever engineering. And this is where the real ingenuity comes in. One method they use is called pigging. Basically, they send a device called a pig, don't ask me why, through the pipeline, and it pushes the cleaning chemicals ahead of it. Another way is through circulation, where they create a closed loop to just constantly pump chemicals through the entire system. Both of these techniques are designed to make sure every single inch of that pipeline gets treated. So, once all the cleaning is finished, how do you really know it worked? I mean, you can't just take someone's word for it, right? This is where the science of verification comes into play. The required level of cleanliness, it isn't subjective at all. It's not a guess. It's actually defined by these super strict international industry standards from organizations like NACE and the American Petroleum Institute. These codes spell out exactly how clean is clean enough. There's just no room for error. And to prove that they've met those standards, every single thing gets documented. We're talking detailed reports, often with photos, showing the before and after state. Every chemical used is logged, and the whole thing culminates in this official certificate that legally verifies the system is clean and ready to go. It really all comes down to this. In these high-stakes industries, if it isn't documented, it basically didn't happen. That paper trail is the ultimate guarantee of quality, safety, and compliance. Okay, so after all that meticulous, painstaking work, what's the actual real-world payoff? Well, it pretty much boils down to 3 huge benefits that last for the entire life of the equipment. First off, a clean system is an efficient system. Makes sense, right? Without all that gunk causing friction or creating blockages, liquids and gases can flow exactly how they were designed to. That maximizes the output right from day one. Second, by getting rid of corrosive stuff like rust and mill scale from the very beginning, you're actually preventing a ton of future problems. This dramatically cuts down on the need for costly shutdowns and long-term maintenance. You're literally solving problems before they even have a chance to start. And finally, and this is the most important one, it ensures safety. A clean, reliable system is a safe system. This whole process from start to finish is a fundamental step in protecting the people who work there, the environment around it, and the integrity of the final product. It really makes you wonder, doesn't it? This whole deep cleaning thing is just one of these countless, invisible, highly technical processes that are always happening behind the scenes. What other hidden sciences are out there, quietly making sure our world just works?